You're up.
Hello, my name is Thane Beattie. I am in the Electrical Engineering Technology degree program, and this is my project. I created a strobe light. Strobe lights are becoming more widely used, especially the LEDs, compared to like the flash tube or other LEDs. They are used in emergency vehicles, road crews, tower signaling, as you see on airports, different things like that, and they're starting to actually implement the LEDs because they're lightweight, versatile, and energy efficient. My idea to make a strobe light, some reasons I wanted to make a strobe light is I use them for work on a plow truck, and I've had to try and repair multiple strobe lights to see if I could get them to work. And I was shocked to learn how expensive they are. Here's one way to make a strobe light. The picture on the board shows LEDs with a transistor powering the 3 LEDs. And this is from a project up in Williston. It's limited. You can only power a certain number of LEDs, which is by the input voltage, and it can't be driven above the input voltage. So I had another solution. My solution was to control the flashing of the LEDs with a microcontroller, with a keypad and a microcontroller, and to have a boost circuit where the output voltage would be boosted above the input voltage to control more LEDs with a constant current, because the current is better when trying to control the LEDs. In doing this project, I had to choose what type of LEDs I wanted to use. I personally picked amber because that's what I work with at work. There are different style LEDs, more than just this, different colors. But the thing that I had to take into consideration with my project is the voltage for the LEDs. The typical voltage for a red LED is 2.1 volts. A typical voltage for a blue LED is 3.2 volts. Same for the green LED, and the amber is 2.2. Now this comes into consideration for my circuit on how many I can put in series and how many I'm able to power up with a chip. So the basics of the circuit, I will use the microcontroller to execute a code to flash the LEDs. The LED boost driver drives the LEDs, powers them up to the brightness that I would like them to be at. And on the board you can see I've got 2 red boxes. Those are the 9 LEDs in series, but it's 2 parallel groups of the 9 LEDs in series. And with this, it has the supply voltage has a wide range, and the output voltage has quite a wide range, different to power these LEDs at different brightnesses. I chose the LM3410. It's a surface mount chip. It's a constant current boosting chip, and it runs at 525 kilohertz or 1.6 megahertz, and that is determined inside the chip. And the reason it runs at such high frequencies is for surface mount technology. It allows the inductors and chip capacitors to be very small surface mount. Some other features for this, its input voltage range is 2.7 up to 14, and the output range is 3 to 24. And it has a switching current of 2.8 amps typical. It can be quite efficient according to the data sheet. You can actually get up to 88% efficiencies. And it has an external shutdown included and ultra low standby current of 80 nanoamps if you would like to do that. And you can control this chip with pulse width modulation. Here's the boost circuit that I created. I'm using a 12 volt input supply. That's what your car is typical. And because I have the 9 LEDs in series at 2.2 volts, it's going to have roughly an 18 volt output. If you look at the oscilloscope, you can see that the yellow one is looking at the output of the inductor. It's taken the 12 volt input and boosted it up to 18. Can't really see it, but there are 5 volt division blocks, and it goes up roughly 3.5 blocks, so somewhere around 18 volts. The lower graph, the blue one, is the output on the capacitor that is charging up to 190 millivolts. And then where it just slowly rides back down until it needs to be hit back up to 190 millivolts, and that voltage is running back to the feedback pin of the chip, pin 3. The dimming is controlled at pin 4.
Before you move on,
yes.
Go back to that slide and point to where the 18 volts is so people know what.
18 volts should be right there.
Okay, but on your picture, on your
Oh.
waveform.
That's the 18 volts.
Okay. So what's the line in the middle where it's flat line? Is that 12 volts?
It's
12 volts, right? It's just when the inductor's not doing anything.
yes, that's when it's going down. It's slowly coming back down to the 12 volts and then getting boosted back up to 18.
So what is that whole time frame? Can you tell us? Is that 1 millisecond? Or?
Each division was about 50 microseconds. So it's roughly 2 blocks, so it's like 100 microseconds.
Okay, so this pattern is repeated many times to get the average
Yes.
brightness you want.
I am using the microcontroller, the Freedom Board KL25Z, to produce the flash patterns for the LEDs. I have 2 simulated flash patterns, kind of hard to see on the board, but one has a very fast strobe light pattern. It is 8 flashes in 1 cycle. That's that. And the other flash pattern is just a on-off, just a very slow flash pattern being sent to the dim pin on the chip. That's the end.
So, can you go back to 2 slides? So on this one, you said the lower pattern was across the capacitor. Did you mean the lower resistor there? The blue waveform?
Yes,
So can you point to the resistors so we can know where it is?
at this point.
So that's essentially measuring the current through the LEDs, right?
Yes.
And that's what's used for the feedback.
Yes.
To maintain that current, okay? And do you have any numbers to give people on those inductors and resistors? Because you did a whole bunch of calculations. What did you end up with for a typical inductor, for example?
My inductor came off of a Xbox 360. It had a point, is it like 0.05 resistance value to it, and I believe it was a very small inductance value. I cannot remember the actual value off the top of my head.
But you did a bunch of calculations, didn't we come up with like 100 microhenries or something like that is what you needed?
We did initially, and I redid the calculations with Correo and came up with the inductor that I ended up using.
Okay.
And it was a very small inductance value.
Yeah, it should be. Okay. Anybody else have any questions? And you said you blew a couple chips?
Yes.
Is that from it overdriving itself?
That is from that was my own personal issue, because I did not have a protection on the chip,
Okay.
and you can have protection. They suggest a Zener diode in parallel with the LEDs.
Okay, so there's no protection in the chip?
There's no protection in the chip. They have a output over voltage protection that you should add
Okay.
to it.
Okay.
And
Do you have any more chips so you can do one more?
yes, they do have one more chip.
All right. All right. Thank you.